two copper wires are joined together and carry a current as shown. Wire P has a diameter D and wire Q has a diameter 2D. What is the ratio average disk speed? This is something which has appeared many times in our course, and there is one formula which is famous for this purpose. This is the formula, and area can be this is area. Now, this is famous to remember that these questions are called ratio-based questions. So if I make velocity the subject, let me make velocity the subject, 4I upon pi n d square and E. This is the formula for V. Now he wants me to make a ratio. So I will take VP V1 upon V2. So I'm not taking the constants, as constants are not the two wires are connected in series. I current won't be different, and both are copper wires, so N would be same. Now we can cancel out. So I'm getting this ratio. Let's see if you solve it, what you get. Let me check if you have solved it. Can you please share if you got any answer for this? Yes, Ali, can you hear me?
I can hear you.
So did you get the same answer?
Can you hear me?
Yes, I can hear you.
Yes, I'm getting the same 2 over 1 whole squared.
Right. Now it's 166 and electric kettle is rated at 2 kilowatt, which describes the power supplied to the heating coil in the kettle. The coil has a resistance of 5 kilo ohm. What is the current in the coil? So we have the power. So we have the resistance. So we can use power is equal to I square into R. I square is equal to P upon R.
I is coming at 0.63 ampere.
0.3. You are
0.
saying
B answer.
you are saying 0.6. I thought you were saying 0.36.
I think there's some internet issue here also. I can't speak very clearly.
0.6.
Because I can't hear you like very correctly right now.
Some issues. Maybe I think it's actually internet is giving a problem mainly here today, and I'm using a wireless device, and wireless devices are actually with less bandwidth. So let's see. Okay, we move to our 165. Which graph best represent the way the current I through a filament lamp? For a filament, resistance increases as temperature increases, varies with the potential difference. So if resistance is increasing, the graph should be bending towards the voltage axis.
So will it be B, the answer?
I think B should, B looks fine. The number density of free electrons in copper is this. So this is N. A copper wire has diameter 0.42. What is the average drift speed of the free electron in the wire when the current in the wire is 0.57?
E we will take as 1.6 into 10 power minus 19. I am getting 3.2 into 10 power minus 4 as the answer.
Sorry, what did you get?
D.
D. You have double checked that calculation, right? Because I'm marking it.
Yes.
Good. The current in the circuit shown is 3.2 milliampere. What are the direction of flow and the rate of flow of electrons through the resistor? So first I would mark positive, negative, conventionally current flows like this. But he is cleverly asking about electrons. So this is the direction of current.
So will the direction be from like positive to the negative?
Current is always from plus to minus. If this is a plus terminal, this is a minus terminal. This is the direction of current, and this is the direction of electrons.
Electrons will be in opposite direction.
Electrons will be in opposite direction. And he says rate of flow of electron. So it is directly asking for the rate of flow of electron is simply current. What is the difference? What is giving per second?
So is it I is equal to Q over T? Like that one?
Because but current is given. That is a bit tricky part because you to see the current in the problem is coming now. We have selected, we have narrowed down the options C and D. C or D will be the current in the circuit shown is 3.2 milliampere. So what do you suggest? What should I do for the rate of flow? He has cleverly given, he has given a good idea. That is the idea of the unit.
I don't get this part. How we supposed to find the rate of flow?
Because one, there is a common sense approach to write the answer that if he's asking for rate of flow of electrons, it cannot be in a negative power, because negative power means less than one. So when something is moving, at least one particle should be there. But I'm trying an option here. Now try that.
It is coming as 2.3 to 10 power 16.
Ali, can you hear me? If you can hear me, please, can you solve this part calculation? Ali, can you hear me? Let's quickly see if you can solve this part for me.
I
We
got
left
2.3 to 10 power 16.
2.3.
Yes.
So that's a good look to be a good answer.
So doesn't n show like the number of electrons?
But I took time is equal to 1. I took time is equal to 1 because he has given me a hint here, s minus 1. So I take time as 1. So I can take 1. So it will be a unit case, a unitary method. So I took it in terms of time, or you can say I leave the time as it is. The rate of flow of electron means number of electrons per unit time. So let's quickly try this question. A cell of internal resistance 0.5 ohm is connected to a fixed resistor of resistance 10 ohm. A cell of internal resistance 0.5 ohm is connected to a fixed resistor of resistance 10 ohm. The resistance of the resistor is changed to 20 ohm, which statement is not correct.
Isn't like the current proportional to the resistance, like it is V is equal to IR. So when resistance increases, the current will also increase. No, it's the other way around, I think. Like when the resistance increases, the current decreases.
Let's first see the possible circuit. Now I made the circuit. Cell of internal resistance 0.5 is connected to a fixed resistor. The resistance of the resistance, the resistance of the resistance is changed to 20. So this is the value change. What statement is not correct? So we have to see one by one. The current in the circuit will halve. We have double the resistance. We have double the resistance. So will the current, it's a series circuit. He says not
Current
correct. Actually, this is not right because current won't be half because there is another resistance small r. This you can see the total resistance is not actually double. 10 plus 0.5 is the initial resistance. If we see 10.5 changes to 20.5. So resistance is not doubled. So the current won't be half. The EMF of the cell will remain constant. I'm double checking it. Otherwise, A should be the answer. The EMF of the cell remain constant. The EMF is the maximum, the total output of a cell. So it is actually correct. The power dissipated by the fixed resistor will decrease. Power is equal to I square R. So when you are increasing the resistance, power will decrease. This is correct. The terminal PD of the cell will increase. The terminal PD of the cell will increase. This is also correct because you are increasing external resistance. You are increasing external resistance. So terminal PD will increase.
So if it was 21, then A would be correct because it's not 21.
Because it's not doubling now. The resistance is actually not doubling. The resistance is 10.5 to 20.5. So it is not precisely, it is not the double. So let's keep it up to here, and we will try to put a class tomorrow, and we will continue this work.